Hey guys, I'm Nick and welcome back to the new tutorial. Today we are again exploring simulations that are driven by the Pyro, but if you're not feeling fancy with advecting the volume with noise or divergence fields or whatever, I've brought you a simpler solution that, as you can see, works pretty well. So yeah, we will be using just a few colliders to make our smoke swirl, and then we can get that data to advect some fluids. So yeah, without further ado, let's open up Houdini, let's drop Geo, and inside we will start with a tube. So that tube will be with an end caps, a y-axis. Radius scale will be 14, so quite a big one, with 120 columns. All the other things are defaults. Then we drop Pyro configure, or no, Pyro source. In Pyro source, let's initialize source smoke, and let's set the particle separation 0.05, and I want to set my density value to 0.2. Also, don't forget that we need to scatter some points inside, so it will be a volume scatter, like that. Then let's rasterize density and temperature. So volume rasterize attribute goes after the Pyro source, and we select the density and the temperature right here. Also, my voxel size will be the same as I used for my particle separation in the Pyro source, so 0.05. And that's basically it for the preparation. So let's drop null and call this out smoke. I don't want the smoke in the simulation to dissipate in all the possible directions. So let's just quickly drop a very basic collider. So it will be a tube with end caps. It will have a radius scale of 15, height of 4, and again 120 columns, so it's a bit bigger than we have our volume. Let's call this out container for our smoke. And then we need something that our smoke will collide with and create these beautiful ripples. And probably the easiest way that I found would be just copying some geo on the circle. Circle will be, let me highlight that. So it will be a ZX plane. It will have 12 divisions. We don't need more than that because we will be copying some tubes on it. For some sort of an animation, I want just to make sure that it rotates 1 degree every frame. So $F in the Y rotation. And for my uniform scale here, you know what? I just went with 1 at the frame 1 and at the frame 30, 3. Then I go back to 1 at frame 60, at the frame 90, it's again 3, then frame 120, it's 2, at 150, 3, 180, it's 2, and 210, it's 3 again. So it's basically sort of a pulse, as you can see here. And this is what will give us these interchanging waves. So then let's copy 2 points, some of our tubes. So connect the tubes to the left input of the copy 2 points, circle to the right input. And of course, for our tubes, let's make sure we have the orientation on Z-axis. Let's add end caps, and our radius will be 0.69 with a height of 5 and 62 columns. Then we can drop null and call this out trail, because this will be sort of a trail for our smoke. At least it will look like a trail. And then I guess, yeah. So I forgot to do that. So let's drop transform and let's scale it by not 12, but 2. And then let's tidy things up a bit. So let's move everything in a row because all of them are sort of logically connected. And then we can drop a DOP network. And that DOP network will need a Pyro solver. It will need a smoke object. Then we need a volume. Then we will need a merge. And for that merge, we will need to plug one static object, which will be a container. and this will be trails. All right, so yeah, let's connect smoke object to the first input of the Pyro solver, volume source for the last input in our Pyro solver, and let's select Pyro, container, and trails and connect that all to the merge. That's how all of them will be on their right places in the merge. And we don't need any gravity, we just need to output all what we did here. So yeah, connect to merge to output. And yeah, let's go node by node and configure that. So we should source smoke, but it's by default it's here, but you need to select anything else than source smoke, and then you go back and source smoke, and then it works. And here I guess everything's default. Yeah, the sub path will be to our obj-go1 out smoke. Activation will be up till the frame 3, just very subtle sort of little amount of smoke. So then for our smoke object, I want to set the division size to be 0.1. Size of the container will be 25 and 20. We can close the borders. So right now, if I press play, we basically have that smoke field. For the Pyro itself, in the simulation, I want to set the viscosity to 1. Then for the combustion, I want it disabled. And for the shape, I want a really like minimal dissipation, so 0.0001. Then for our container, let's select our subpass, our out container. For the collisions, let's use volume collisions and let's check collision guide. Right now you can see it's very, very low poly, so let's set the division method by size and I think 0.1 will work. Let's invert the sign, and despite of the missing top part, I think this should work. And for our trails, let's select them. Let's check use deforming geometry. We can uncheck display geometry because let's again check what we have here. We will be using volume collisions. Probably should set that by size too. We can now uncheck the collision guide for both of these. And yeah, I guess let's simulate a few frames and see. So yeah, this looks good. That's how it should be. And as it goes, you will see that because the smoke has this viscosity, we will get some nice looking sort of trails, or I mean swirls probably. So yeah, I suggest you simulating all the way up to 210 frames, because as we progress with different scaling of the circle that we copied our tubes on, we will get more and more detail. And if you want even more detail, probably increasing the viscosity will give you even more detail, as it will be more like a fluid-like thing. So so far 60 frames look like this. Already pretty good, pretty symmetrical, really like this. And basically it will work as velocity field for our second simulation. So first of all, we will need to uncheck that we need all the objects. We need just the smoke object from our DOP network. And yeah, that's interesting why we still have these right here. But anyhow, let's import the fields from our DOP network. So drag that into the DOP network of the DOP import fields. And here we can choose the preset smoke, and we can, it's here. So let's drop file cache. Let's get around, actually for this one, I think I will need just 150 frames. I think that will be enough. So let's simulate that and let's see what we got. Because our voxel scale is not that big, it took around like 2 minutes probably. But yeah, look at this. I think this looks pretty good. This looks really interesting with all the swirls and the symmetry that we have. So yeah, now we can just drop another null and call this out v, because this will be the velocity that will drive our volume fluid. And the thing is, this doesn't have any gravity. And essentially, if you compare smoke sim and just pure velocity from the smoke sim, it doesn't have this flow that is often seen on the fluid simulations, because the fluid, it kind of wants to swirl and is affected by gravity. It might not be the clearest explanation, bear with me, I'm pretty sure you will see the difference. Because right now, if we just, I mean, it's obviously the wrong thing to do, but if we do the points from volume, you can see, first of all, they are deleting when the density is below certain threshold. But even if I set the jitter seed, or I mean jitter scale, I mean, it doesn't feel like a flow. It feels more like translating particles from one position to another. So that's why, let me drop another tube, and we probably can just copy this one. We will place this right here. This one will have a bit less height because we don't need that much, to be honest. So the height will be 0.7. It's all the same tube except the height is 0.7 right now. And the points from volume that we will have will be 0.05, but with a slight jitter of 0.5. And we will need to add a scale attribute, and particle radius scale here will be 1. Then let's drop volume configure fluid. We don't need to create the points from volume, we just need to get our points that we have right here. The particle size will be 0.05, and let's just check viscosity, friction, repulsion, whatever it is. Let's just check it. And then we will have our two nulls here. One will be out geo, this will be out con, and let's connect constraints to out con and out geo to the geo. Then let's drop another dop network and let's dive inside. This will have our vellum solver, it will have our vellum object, vellum source, and it will have a merge and a ground plane. I won't do this in a collider, in a sort of container. So yeah, it will have just a ground plane. Let's connect vellum object to the left input, vellum source to the right input, select ground plane and vellum solver and connect those two to the merge, and merge goes to the output. In our vellum source, let's select our out geo as the subpass, constraint subpass is our out con, and we can already drop pop advect by volumes. And here let's select our out v, field name is velocity scale, I want to up it up to 2, and I want advection type to be update velocity, with the velocity blend set to 0.7. I forgot that we will need gravity force right here, so let's add it. So right now, if I simulate this, it goes a bit slower, but let's probably go to the frame 60, just so we can see what's going on. And this file cache will be a bit heavy, but already now you can see like how beautiful it will be when we file cache it. So yeah, that's what I told you about. So we basically have these particles flowing like that. So the motion is quite different than just basic smoke advection in the pop network. So yeah, that's what we are aiming for. And there are a few things that I want to add. So first of all, I want to do pop axis force to further enhance how they rotate. And this pop axis force will be quite small. Let's get back to the frame 1. So I will have my radius at 2, and I just want to introduce a bit of that suction force. So let's keep it at 2 and the orbit at 1. And also I want it to be very smooth, so let's do soft edge at 0.5. Then we definitely need a bit of drag to make the motion even smoother, so just a pop drag at 1. In my vellum solver, it's all default right here. And then I want to add one more thing. So it's up to you if you want to do that or no, because I thought would be pretty cool to add something in the middle. As you saw, there's a sort of a ring, like it's from the older members machine, the Aura ring, I think. So yeah, let's just add a little inset, sort of an inset right there. Let's add a tube. I want to visualize this. No, I want to visualize this smaller tube, and this one will be wireframe. So that tube will be on y-axis and caps checked. I want to make my outer radius at 1, and then I want to add a few columns to like 32 or something. And then I will use a group on my points that I scattered or like made a volume out of my bigger tube, the disk one. And I want to target the points that are in the bounds of the smaller tube that we just created. So let's group by points, and our base group will be, no, we will be keep in bounding regions and bounding object. So now if we check that, yep, we have these points right here. And let's just delete these points. So I'll drop a delete after the group and select our group, and our entity is points. So now if we delete, cool, we don't have them anymore. Another thing is I want to shape them a bit, and I don't want them to go inside of that circle. So, and because they tend to go up, we will need a poly extrude after the tube. And here let's just select the top face like that, and yeah, extrude it, I don't know, 4, 5, something. And let's drop another null, and let's name this out, I don't know how to call it. This will be a collider 2. Another thing that I forgot to do is after our file cache, let's add a transform, and let's push this just a bit up to 0.28 in Y. I do that because I don't want lots of the blank spots, as you saw in that swirl that we simulated in RAM. There were quite a few spots where all of the particles were sucked into that swirl. I don't really want to do that. I want a thin layer of some particles laying on the ground. Now let's get in our .NET and add that collider. So it will be a static object. Let's connect that to the merge. Let's make sure that the static object is connected on the left side, or it's the first input in the input operator. So then our collider 2 goes into the subpath, and we will need, again, volume collisions. We don't need to display the geometry, but let's check that we have enough on that resolution. So I don't think that's enough. Let's set this to be by size at 0.1. And yeah, I guess that's it. Let's make sure that we don't have that collider in our output objects. We will need just the volume object 1. So these particles here, and let's do the file cache. I will do just around, I don't know, 120 frames. I actually did 150, but just to save time, let's do 120. And the file paths will be explicit, and yeah, let's hit save to disk. And here we have some frames. So yeah, here you can see the motion. I think it's pretty cool. And yeah, I guess let's set up the scene. There are a few things we should do. First of all, I want to colorize these based on their speed. And I will animate the range of that speed. So as you can see in the intro, they gradually become more and more golden, or yeah, I mean, we sort of switch or tweak the n values of the attribute that we colorize from. So yeah, you can do whatever you want with the gradually transforming the look of these, I guess, sand grains. So yeah, it will be the attribute wrangle that we will drop after the file cache. And the thing is, we want to grab an attribute that is calculated from the velocity, and it will be the speed. So at speed equals length of our velocity, so at v. And then I did a retime here, so I basically retimed that to be twice as slow, so 0.5 in speed, and the range will be from 1 to 120. output frame range will be 1 to 200. And then we will need to create a scene around it. So let's drop merge right here. And for this one, I will be using a box. So connect it right here. Let's make it proper way. And so that box will be, and that's based on my camera. So it will be 20.772 on X, it will be 0.3 on Y, it will be 21.179 on Z, and we will need to show you that box. And then it will be minus 0.832 on X in like centering, minus 0.624 on Y, and 1.304 in Z. So that's purely based on my camera and where it will sit. So then I want to drop points from volume. These will be, let's probably, let's do this right here. So the point separation for this one will be 0.03. And I don't really know why it's not showing me the points from volume that I have here in the merge. Because right here it's all correct. I don't know. But for these points from volume in a box, I wanna, it's sort of a trick that I like to use. So we need this density because I wanna keep them at this scale. And we need to add a scale attribute. So I wanna keep them at this scale, but I don't need that much of them. So I will delete like 60% of them here in the random type of deleting particles. And then I will be using point replicate right here to make the surface a bit more jittered, I guess. Just make sure you don't make my mistake and click on the point replicate right now, because it's set on 100 points, replicated points on like per region. And we definitely don't need that much. I usually keep it like 3 to 5. Then for the shape, I want to go with the sphere and set the uniform scale of that sphere to 4, and then add some noise. I love this all default. And don't forget that you want to copy the attributes. So copy source attributes and keep source attributes. I'm not sure what this keep source attribute does if we are copying the source attributes, but I usually like keep both of them. And then you can see they became a bit more jagged, and now we can see both of them. So I guess I'm gonna need to push it. I will need to push it up. This will be probably at either 0. We will need to push it down a bit. So let's try 0.1 minus 0. I guess this works. Should work. So and then we want to colorize these. So let's drop color after the merge, and we will be colorizing this based on the attribute, and our attribute will be speed. So here you can see how it is based on that speed. We probably can drop this right here to make it a bit more prominent. And here's the deal. So at the frame 1, I want this to be from 0 to 15. So basically everything will be black. And based on the motion that we have at frame 210, I want this. Oh, we need a key. So right here, and 210 will be 0. So everything's white. And we probably can keep this at default Bezier curve. I think we can do that. But you can adjust these as per your liking. And essentially what it gives us is starts small, and essentially it spreads to the whole surface of that spinning part of the particle. And so that's basically it. So let me paste my cameras, lights, everything right here. And you can see here I have my GO2, which is just a basic tube. Probably let me switch off the grains. And it's basically a tube that was poly extruded. I've added some UVs, And I just keyframe the transform. Here's one rotation, there is another rotation. Then the third transform, I just scaled it up a bit, and yeah, that's it. Now let me go to the Geo1 and make sure we are rendering this as particles, and I can assign my material that we will be talking in a minute. So this will be a sand, and this will be ring. And I guess my ring sits a bit too far inside, so let's move it up to 0.5. Around that should be pretty good. Yeah, now let's fire up the redshift, and yeah, let's go and see the lights and also briefly check the material network. And here we have it. So at frame 120 it looks like this. The main thing here is the camera, of course, which is like this, and then we have two light sources, one shining from this side, which is, let me do off. So that's just one light right here, and then we have another one which shines just from another side, and that light is set to shine only on the ring, so it doesn't affect this part right here, the grains. And then to subtle the shadows and bring a bit more light, I have my RS light dome at 0.4. And for my material network, it's very basic. We don't need even this grid one. So yeah, this one is rough black plastic, and this one is a gold preset. I just changed the reflectivity color to be a bit more like rose gold, not that yellow. And I'm using the color to then drive my blending in the material layer. And the ring is just, yeah, pure gold material. You can also see I have quite a shallow depth of field here, and I think it really enhances the look of this scene. And what else we need is to go into Redshift OBJ and use Mesh Deformation Blur for velocity attribute, from velocity attribute, and then we can go to the Redshift OBJ and click on Vent Stretch and enable the deformation blur. Make this custom. I think this will work for us. And yeah, motion blur really adds a lot, especially in this scene with all the swirly motion going on. Looks more like a flow than separated sand grains. So yeah, don't forget that I always use post effects, and this scene is not an exception. In the optical, I decrease the exposure because I really want this to be a bit darker than it is right now. But you can push the highlights to further enhance the ring inside of that swirly sand sound. So yeah, I guess that's it for this tutorial. I really hope you enjoyed it, and yeah, sometimes you don't really need to do complex stuff with smoke. You can just like use a few colliders and it will already give you that nice look. And I think this effect is really popular. I saw that numerous times used in all sorts of commercials. So I think adding that to your knowledge base or toolbox will be very handy. So yeah, that's it for today, and I want to thank every one of you for supporting me here on Patreon. All the tutorials I do is only because of your constant support here, and I really appreciate every one of you. I will be back with a new tutorial very soon. Bye!